Hi everyone. This video is about the rules for error propagation, which again is related to our second course goal. And the rules for error propagation, much like the rules for sig figs, depend on what type of arithmetic that you're doing. So when you're adding and subtracting, you want to start with the absolute error first. Start with the absolute error first, then convert to percent relative. And I always find this to be a little bit easier because often in the problem we're given absolute error and we have to use a formula. The formula that we use for addition and subtraction is the absolute error of our sum or difference is equal to the square root of the absolute error of our first measurement, E1 squared, plus the absolute error of our second measurement, E2 squared, plus the absolute error of our third measurement, E3 squared, and so on and so on and so on, depending on how many different measurements you're adding and subtracting. So why don't we try an example, and let's imagine that we were doing a titration. And when we began the titration, we recorded our initial volume, let's say, as 0.50 milliliters. We did the titration, and then we recorded our final volume as 25.65 milliliters. So we computed our total volume as 25.15 milliliters. But the thing is, when we recorded this initial volume, there was an uncertainty or error associated with it. And for most burettes, that uncertainty is plus or minus 0.05 milliliters. And the same was true when we recorded this final burette volume. The uncertainty associated with that volume was also plus or minus 0.05. So how do these two uncertainties, how do they propagate into the uncertainty of our total volume? So we're going to compute E using this formula. Here we go. The absolute error of our result is going to be the square root of the absolute error of our first measurement, 0.05 squared, plus the absolute error of our second measurement, 0.05 squared. And when I did the arithmetic, I got 0.07 with an insignificant 1. So we could say that we delivered in the titration 25.15 plus or minus 0.07 milliliters. We've expressed our volume with its absolute error. But if we wanted to, we could also express this as percent relative error. Let's try it. The percent relative error would be, again, ask yourself, 0.07 is what percent of that total? So it'll be 0.071 over that total volume, and then multiplied by 100 to convert to a percent. I got 0.2 with an insignificant 8%. So we could also express the total volume delivered as 25.15 plus or minus 0.3% milliliters. So that's how we propagate error when we add and subtract. When we multiply and divide, we have to use a slightly different formula. I'll show you that on the next video. Thanks for listening.